Okay, this week we're going to finish chapter 3. Okay, we'll do the last problem from your book, the example problem. That should be very easy to you now. And then we'll do a few more from your textbook. Did everyone got a copy? Okay, so let's take a look at this problem. The blending problem. I'll give you a few minutes to read through it, and we'll talk about it together.
Yep. Just like the hydrostatics problems and how to for some reason, even though they make sense
Okay, everyone finish reading? So what does the farmer try to do? Try to put a good mix using those 4 different feeds to meet the requirements of those minimum percentages of corns, grains, and the minerals, because each feed contains different percentages, and by trying to mix them together, he can achieve this minimum requirement. And at the same time, those different feed cost differently, right? So what do you think? What's the objective? Minimize the cost. So he wants to get try to get that right mix that just meet those requirements, but at the minimum cost. Okay, and they ordered for 8,000 pounds of them. Okay, so the decision variables would be what? So what is trying to decide? What's that? How do you mix them together? Okay, then translate the 2 variables would be, how do you mix them together means
each feed would be a decision variable.
How many pounds, or like how many percentage of each pound in that feed, right? So which way you want to go first? Should we do like pounds? How many pounds in the mix? Or like what's the percentage of each? So there are 2 ways, again, 2 ways of deciding. It's kind of like that investment problem, remember? Investment problem, you can do percentage of each of your money put in each bound issue, or you can do actual amount of money to put in each. So here's the thing, actual amount in terms of pound in the feed, in the 8,000 pound, or you can do percentage of it. Probably we'll do the pound first, because the percentage part is a little more abstract. Okay, so we'll do the pound. So the decision variables will be, we can do like F1 F2, F3, F4. Okay, so I'll do Fi. Okay, so pounds of feed I to put in the mix. Where I goes from 1 to 4. Then our objective function. So we want to fill this order at a minimum cost. So if we have we use 1 pound of feed 1, then that will be like 25 cents. 10 pounds of feed 1 will be $2.5. And then F1 pound of feed 1 will be 0.25 F1, right? And so we add them together. So F2 plus 0.32 F3 plus 0.15 F4. So very easy. Subject to the constraint. Subject to the constraint. So they're just like two very one group of constraint very obvious, because it said they want this feed to contain at least 20% corn, 15% grain, and 15% minerals. So for each of those ingredients, we can have just one constraint, right? Okay, so let's see. Let's do the corns first. Okay, for the corns, if we use feed 1 contains 30% of them. So 30% of those F1 will be the amount of corns you brought in from the first feed. Okay, so let me use percentage. So 30% of feed 1. So if you put, if your F1 is 100 pounds, so 100 pounds of your feed 1 will include 30 pounds of corns. Okay, and that's how we represent it here. So the 30% of your F1 is corns. Okay, plus, then from feed 2, we're only looking at the corns now. So plus 5% of feed 2 plus 20% feed 3 plus 10% feed 1. So those are all the corns measured in pounds. Okay, need to be this at least. So greater or equal to 20%. And see if it's right. Tager.
Yeah, is the last one supposed to be feed 4? Or, yeah.
What's that?
You put F1 for the last.
Oh, sorry, yes. Yeah, that's, thank you. Okay, thank you.
Would it be 20%?
Anything else?
20% of 8,000?
20% of 8,000, yes. Why?
Because the final mix has to be 20% corn, and they order
20% of the mix, right? Okay, good. So if we write, many people make this mistake saying, okay, so the corns need to be greater than or equal to 20%. But it's the 20% of your total mix. Okay, and if you write this way by a check of the unit on both sides, you will find, okay, so these are like a pound, right? So 30% of pound is still pound. So on the left-hand side, it's pound as the unit, and this side, it's just a percentage. So it's not right. So it need to be 20% of the 8,000 pounds. Okay, so that's the main part I want to call attention. So then the rest you can do it. So we'll look at the green. So 10% F1 plus 30% F2 plus 15% F3 plus 10% F4. Greater than equal to, now we're looking at green now. Okay, and the green we want 15%. So 15% of 8,000 pounds. Then we'll do the minerals, 20% plus 15% F. So we're looking at this row now. 20% F2 plus 20% F3 plus 30% F4 greater than equal to 15%. 8,000. Okay, so that's for the 3 ingredients. Anything else?
Non-negativity.
Okay, non-negativity. Fi is greater than equal to 0. 1, 2, 3, 4.
Do you need the non-negativity constraints for this one?
What do you think?
No, because they're already bounded. They have to be greater than already.
Okay, what do you guys think? So I think what Cody is thinking is because you have these ones. Okay, but can that happen? For example, this becomes really big value. This can go negative, right? When they are combined.
I actually saw that happen.
You are right. Okay, you are right. You can have negative feed. You are right. So that's why I was thinking, okay, we should add this constraint. But what Cody is thinking is that, well, because of those constraints, maybe we don't need it. It's I think what he's thinking is similar to the production problem we formulated last time. Because we have like the PIs, the productions need to be greater than equal to 1,500, less than equal to 600, right? In that specific problem, because all the individual decision variables have their lower bound. But in this one, it's hard to tell. Okay, so we do need a non-negative constraint. Yes.
Got 'em.
Okay.
I tried that in the solver with that production problem, you know?
Okay.
First, and I forget if you, one of you guys helped me, but it actually wanted to produce negative. numbers. It did that. It went
Right,
negative
right.
with 1 and negative, and then I had to go back in and I forgot to check that non-negativity box.
That what may happen. Why? You see, some of those has very big cost. So when the solver tries to big mistake here again. We want to minimize. So we want to minimize. When the solver tries to minimize it, because this one has a big cost, so solver will think, well, what about if I just make this positive and those one really negative? Then that will bring the cost down, right? Okay. Okay. Anything else? The constraint, Martin?
Some of that, some of all F's equal 8,000.
Some of them, yes. Okay, I'll go to the next. So the F1 plus F2. Remember, we defined them as how many pounds to put in the mix, right? So we do want our mix to be like this. Okay, or we can do greater than equal to. We can do greater than equal to. Because our objective function is to minimize the total cost. What do you think? It won't produce more than, it won't put more than needed, right? So putting this as greater than equal to is will give you the same value as equal to. Okay, so that's the constraint. Okay, then for this problem, there's one special thing that I want to talk about. I'll use my slide. Okay, so that's called a scaling problem in solving the problem, in solving the LP models. It's in this problem, the way we defined. So this is the way we define the model. Okay, the constraints. There's also a different way in writing this constraint. If we think in this way, okay. So those are the total number of corns, total pounds of corns, okay? Divided by the total, like the 8,000, that's like the total pound of the mix. So the corns divided by the total mix need to be greater than or equal to 20%, okay? And the grains, same. So the pounds of the grains in the mix divided by the total weight, like the 8,000 pound, greater than or equal to 15%. Same here. So this is another way of defining the constraints. That's right? It's basically move your move the 8,000 from the other side to be the denominators. And when you talk about it, it makes sense. But if we define in this way, there will be a potential problem called the scaling problem. When you solve the problem in solver, the solver will give you an error message saying like the linearity is not satisfied, or it may say like the solver cannot converge. What's the reason? It's not because it's nonlinear. Well, divided by a value won't make it nonlinear, right? If we're dividing some variables in it, it will make it nonlinear. But in this case, it's because of the big gap. So notice the coefficient for x2. So it's a 0.05 divided by 8,000. That gives you this value, okay? And then the solver runs. It will, the storage problem will force the computer to use approximation of some actual values, and the scaling problem sometimes prevent it to be able to solve the problem accurately. And that's because of the big gap between this value here. So your minimum value in this case is like these ones, and the biggest value was if we go back here, was this one. So in the same model, let me change the color. So in the same model, you have one value that's 8,000, and the other value, for example here, this one we just circled here, 0.000625. So there's a big gap between them, and that caused the solver a problem, that the solver will not be able to analyze this problem. Okay, so to solve those problems, make sure we define that way. So either if we want to solve in this way, we will use unit, like 1,000 of pound as a unit. So on the right hand, it's 8, okay? And then you can do this divided by 8 for the constraints. So the gap between your biggest number and the smallest number is not that big, and it won't run into problems in solver. Okay, yes, question?
So the big small gap thing makes sense. Can you run through that one more time? What's solver doing with those the big little number that causes it?
Oh, okay.
To have problems?
Here?
Yeah, because I'm just kind of trying to
Okay,
understand.
so
what
solver
this
runs,
is doing.
it makes some intermediate calculations to try to, so when the solver solves, it try to increase the value a little bit and then little bit again to circulate to say, okay, if I change to this variable, what will happen?
Oh, to see where it lands between that 0.00065 and 8,000?
Yeah, so those coefficients will determine, like, if you have two variables, it will determine like the slope of your curves and also like the boundary of your feasible region defined by the constraints. So solver basically search within those boundaries. We haven't talked about how to solve them. When we talk about how to solve them, will be easier. So solvers try to search among those different points, and then when it goes from a big number to a small number, here,
Just
it will try to find some approximation values there, and cause like the memory problem. So solve the memory problem, and it will say, okay, probably the problem is nonlinear. Okay, so before we redefine the problem, the smallest value is here. After we define it, the gap is between 8 and this one. So the gap shrinks and minimize the risk of solver thinking it's a nonlinear problem. Okay. So last Thursday, one of us, Anna, I think it, actually ran into the problem in when we formulated the multi-period cash flow problem. Remember? So I said, maybe if I can, I try to share it here, but it's a Mac, I cannot project it. So when we change, like on Anna's computer, it said the linearity condition is not satisfied. And once we delete those zeros and resolve it again, it found the optimal solution. Okay, so that's one problem I hope you can keep in mind if you run into the problem, or when you formulate models with very big gaps between those numbers, try to use different unit, like okay, use 1,000 as a unit. Okay, so that's for this one. Okay, now we're going to talk about, okay, so did you bring your book? Oh, I forgot mine. So for this one, I'm going to ask you guys to do it yourself first. Okay. If there's anything that you don't know how to write in the formula, write in the sentence.
The take-home test that she gives you, it took me like 6 hours.
I'll take a screenshot.
I did it since 18, which should give more.
It's problem 18. Problem 18. Yes.
119.
Okay, so make some copies.
Yeah, I need some coffee.
Copy. So, also your copy. I just thought about it. Maybe we should bring some coffee for class. No one falls asleep. Okay, how many copies do we need? Just the one copy. Just the one copy, two?
No, I don't need any coffee.
Okay. Okay, so then I'll ask you to think about the decision variables. And once you have the decision variables, raise your hand, I'll come take a look.
For which, I haven't started. She did it.
It takes a while, yeah. Because you have to do a bunch of charts. Yep. And then explaining some
all of them added
takes
up
a while. It might not take.
What does she give us? So each one of those models.
Yeah, like the side column. She had, like, yeah, she had that template that, like, yeah, those are the only two I don't have done. But I don't know what
Each week, so there's newspaper ads, numbers, ads.
Oh, yeah, that would be fun. So you like
This is a bunch of
an example of a side project. But that's
It's only gonna be two.
I don't know. That's the only one I didn't know.
So we bound.
If X is, so let's say X is 1 to 10, then equals 945. If X is equal to
Where they're trying to maximize
yeah,
the number.
so.
Decision variable
I mean, maybe.
No, not yet. So what's this?
6.
Did you have it? Oh, you don't have one?
Well, when you do an Excel file.
Okay, I'm gonna try.
I think we have 6 variables. Because we can't purchase, we can't purchase 9 newspaper and 12 newspaper.
Read this.
You can't use this
Yeah.
variable and this variable, and it's only one variable.
Yes.
Okay.
Yes.
Thank you.
That's the first step. Yes.
Nice. Oh, good.
Okay. You can.
How do you write that? You just have to write that.
You can use it.
Sure.
Let me see.
So we're only have two decision variables?
Oh, only two? Okay. You probably need more.
They have 6 decision variables.
Okay, good. That's on the right track. You probably will still need to use.
Still have 6,
Yeah.
yeah.
So X1,
So
X2, X3.
Just added the.
T1,
So that's what I tell you, post like, then you're up to the
Something
page.
about So everybody agrees what the transition is, right? You try to decide how many
N1
newspaper
times.
ads, how many TV ads you add. But because they have those differences in the three
We
groups.
don't need to even use.
So using just one variable to represent how many newspaper
until you
ads
get
to buy probably won't work. Right. You will probably still use if statements,
Oh,
but we
yeah.
want to do
You don't need to write them here, you put them in Excel.
later, no,
Yeah.
later. We can use Excel, we'll talk about it, but then you can write it on your paper.
Okay.
Okay, that's the first step we're going to.
Sure, whatever.
Where are you? Okay, so you have 1, 2, 3, okay. Okay, good.
Minimize.
So
You want to minimize. So wait, you only want to max the
Yeah, you want the max.
customers, right?
Max that.
That's just like, we have to write that later.
Yeah, we want the max number of new customers.
And that's that should be our if type
For the
thing.
least amount. of-
Yeah, you can add that condition there, yes.
For.
Okay,
Or is it the least
okay,
amount?
so the decision variables you
It just
will,
says maximize the number of new customers reached by advertisers, which is slightly different.
okay,
So
okay.
why wouldn't we just?
Yes, yes, yes.
So wait,
yes.
so
So it's not-
we're just gonna use the number of customers.
Okay, so remember what that, like you use more variables.
Yeah, why won't we just use one
Yeah.
That's what makes sense.
Because we're
Yeah,
trying to minimize
so
the
like,
cost while
if it's difficult to write just with one or like less variables, use many. Remember what I said, we just define their relationship.
No.
We've done that before?
Yeah, you have.
We know.
But is there one?
We're not talking about.
There's, oh, it gives us money, hey, we have some. Okay, we're.
Yeah, so maximize it based on.
Yeah.
Times 1,000.
Okay, okay.
Yeah.
Well,
Why don't you use the number of
N1.
When it's
Screw
just
it,
the
okay.
number possible.
Actually, it's Sandy.
No, because
Has to be
we have.
less
How many
than-
times do you add it? So it's.
Variable is
That's
not.
the
T2 plus condition 3
Okay.
is going to equal 15.
Yeah, we have a constraint.
Oh.
There's some simple constraint you can just write them by yourself.
So the condition.
I'm sorry, Colin,
We have to say within the.
And
You did.
when?
You can do classified, brush off, it's fine.
Yeah, no, I never said anything.
Yes, you did.
No.
Yeah. Or maybe you did on purpose. We'll go with that.
Okay, I'll stop.
Were you gonna, I have a raging.
Cost per ads. So
remember it's about the condition variables and many of these is less. Because of objective function.
It's like what's two? If T is bigger than one, is these good
Okay, and don't make the mistake I made, put the minimize, maximize. Okay.
Oh, yeah, for sure.
I know.
Your object function, put the minimize, maximize.
Maximize.
Okay.
Right? For ads, we have customers,
Yes. Okay, so maximize the number of customers reached. Okay. Then you can do the simple constraint.
Budget.
Yeah, so that means cost
Okay, okay.
subject to
So what do you think about that?
1,000.
Okay. Why do you think about that?
We're doing this.
We're trying to figure out how to like get you
End up with 2.5. You wanna do 3, right, we get the point there, right?
to do like each end to create an
Okay.
Oh, you get the first.
Oh, wait, no, I'm writing prices. You wrote it wrong.
So I wrote it down.
Yeah, you did. No, you didn't, yeah, you didn't.
Why did I do it wrong? Was it supposed to number of customers?
Okay, hold on.
I was right.
If this is a
You guys were wrong.
No, you're never wrong, so.
Okay, so we're maximizing the
Trying to get more.
Right, you have to find it. And then you can start setting. Okay, then think about what's the relationship. If you write if statement. Yeah, solution. Okay.
Yes, we got.
Subject. I only.
This is where.
I'm not saying I was
Okay. Okay. Hold on. Okay. So maximize.
ready for the check.
Yeah.
Yeah, so, right, because if they did.
Okay. Okay. So maybe maximize
Maybe just then one means newspaper.
Yes.
But it's like.
What are you talking about? What, yeah.
Before you start talking.
I needed it because I had no.
I was, you can sound very, tell me what you want. Yeah, but I don't know if I have all.
Okay, well, I'll just have to.
Yeah, like different.
Deal. Pack of beer, huh? What's a pack?
What's a pad?
What is a pack?
6.
Not worth it, not sending them. Oh, just kidding.
Well, I'll
Just kidding, just kidding.
Or I'll get you.
Give me
I'll get you
Let me look here. Because I'm assuming.
One of them?
Yeah, so, yeah.
Okay.
Yes.
I'll give you, now your father's.
Because I know.
Now your father's music.
That's against those.
I'll use with that.
Deal. I'll take a pack of that.
I don't know if I read this too, like you use.
Yeah.
Old person.
Okay.
Variable thing, you know, for.
Subject.
You can ask the department. Yes.
Assume the company will purchase.
Okay. Okay. What about
Like if they did,
Okay, you got it.
they did enter.
I did. Thank you very much. It's wrong, but I wrote it. Because that's where you need your if statement.
Because.
Like I already have. Think about the way when you find out.
That's where you need your if statement.
It's like, okay, I have to, anyone who's 13. That's great. That's 2.
Now I gotta drive back
Everyone
to
gets
in the snow.
And then you can say, okay, and like, let's say it was 1 in 9.
Tomorrow the 31st?
Down, it's quite expensive.
Yeah, but it might be.
Right now, it's supposed to, it's ending in like 15 minutes.
Yes.
Okay. Right. If you want to write if statement, that's fine. Okay, maximize the number of yes. Think about the constraint. There's one obvious constraint that you can write. Then think about the relationship between your and what you want. Okay, so that's, I think you can.
Oh, yeah.
Hey, quit littering. Why are you flipping?
It's an environment.
You must.
It's been like a month now, right? Yeah, I know that when I was to
Okay, so.
I went there and I lost that day.
Oh, yeah. So if you.
Well, it would just be number of customers per day. Because that's for each individual. Yeah, so then it's just one day just treat it individually. And these are just gonna be each
Yeah,
turn.
okay, it's defined.
Number of customers reached.
Yeah.
You were thinking about that. Then you can write you said
My room is starting to
that if
I feel like it's
you
No, you do have to define it.
Yeah, so you can write it in that format. You do get a just write like for example if you and choose to become
one subject.
But then, yeah, this looks like we're maximizing. So now we're.
you're already writing from
It's
your
half the ground. Probably the size of this table, not this one.
if you're already if you're entering if you're entering all the people, meaning you are buying something. Because I thought what happens if you add that in? Everyone has to be equal to one. No. No. Even I guess on that same
You have to define it for ads.
if it has to be one, then you're saying
It's
you
like
are buying
the,
a particular paper ad.
it's
And
like
then you're
this
already trying to
problem.
show that it
Yeah,
can.
number should be first.
Yes, okay, okay. So then do the same.
First month,
Okay.
defining part, so we have ads.
Good.
Part, that's one of those statements.
You're already in 6th chapter. Okay. Okay, so you are doing that. Okay, so your exit that.
Throwing stuff at the wall.
This is very, very fun.
Oh, wait, so that would be another constraint.
Yeah, okay, but your M are from
Oh.
Oh, it's a yeah, should be per ad. Yeah. So like they put it together, so like you chop down okay.
So this would be.
Yeah. Yeah. Yes. Well, you don't need to use it here yet. Just the update. Okay, so what do you think is the update?
Because.
Okay, so what's the update here?
Customers.
Yes.
Right? I'm trying to figure it out.
Okay, so
this is per ad.
Yeah, and then if
You have to, yeah, you have to pretend.
Okay.
If you do,
here, right? One, two.
Yeah, it's correct.
Also,
Yeah,
here
so
you
we're
have
just
like,
not, or can't you make it?
one,
Still, you need an if
it's not
statement.
one, 30, you don't
Okay.
need
Because
that.
I
Only
don't
one
have
was
to,
because the one,
because
okay,
don't
you
you have
don't need
to,
that many.
but then how do you, what are those costs
You
per
can,
call?
you can have that many, but that will make it better. Okay,
Yeah, but I'm, these variables too, because if you do one, if you do, 10 ads, you get 900.
no,
Or is it 900 per?
per customer,
Oh,
per customer. And the year, if
That
it is
makes-
a variable.
I thought it was,
My motorcycle's still there.
10, you got, right?
Oh,
And that's why I was
okay,
confused, because I was
oh, I
like,
see.
Plus,
Okay, here.
The part that
Okay.
confuses me is like the objective function says we're maximizing like the customers reached, but our variables are the numbers.
Yes. I'm going to take 5 minutes break and we'll come back and talk about it. Okay. Oh, you know what?
okay. Go this way, too. But then how do you write?
Oh, yeah.
So you could just rewrite those.
Basically, you have the same thing. Yeah, we have all the same stuff.
it would just be 901 plus 702 plus
Oh, it could be.
plus 10,000.
It could be.
Think in a way. Yes, the normal.
I don't know how to do it, but it's one where it's
So
like,
if your n
The inventory.
equals to 10,
Yeah,
that means
we're
you have
shy.
10. Okay. What about here, n2? If n2 equals to 10.
like the beginning inventory plus the
So your n2
production of the one minus the demands and the something like.
So if you represent in the group, if you go from 11, that means if n2 is 11,
That's like not a constraint, but it is, like you have to put it on Excel, but it's not beyond a
for all
constraint.
of them, we are.
When I saw the
Does that make sense? Makes sense now? Okay. Okay. No.
Yes, I
Go back, but that's on the right side of the statement.
That's the first one.
So you're subtracting them? You don't need to subtract them because you already defined
But
it.
the second one.
Because your
I know.
is the
Well,
number of
it's-
newspaper ads in this sentence. So
Okay,
if your
so we have it like
one,
this.
that means you
She
are
said it
defining
for this.
the
We have it,
So you're saying, but architects have to be sure, all our ends and all our.
So I didn't change it.
Yes, yes.
Yeah.
It's totally fine, yeah. Right. That's the simple. I see what you're saying. Okay, if you do this one, then you have to, like your objective function will have to choose which one to use, right? But there's no way we can choose now.
Well, that's, or you do your constraints basically with those
So it's
ifs.
like, okay, when you get the first group, then
We
you
have
go
those.
to 10. When you start to get the second group, and two will be 1, 2, 3, 4, 5. And your total will be 11, 12, 13, 14.
Almost thought ours, like, solver was really not like.
Yeah, I was here for that.
Yes, that's the part of it.
Okay, that's what I'm trying to.
Okay,
that's
yes,
what-
yes, yes. That's the part, we'll try to put the statement, say, okay,
If say,
if n2 is 1, or n2 is greater than 0,
yeah,
what
that's,
should you have?
if that's equal to 10.
Yes,
Yeah.
yes.
So that's
Okay.
what I'm saying.
Yeah, that's it. Yes, yes, it's like the way you define your decision variable. Yes. Oh, it's okay, you did great. You get those right. And those ones, we will use them later. Okay, we will use them later. That's right. And then we need to think about your Ni is in the group of, for example, your N1 is in this group. So it's valued from 0 to 10, right? And your N2 is in the second group. In the second group, that means it's from the 11 student to the 20 student. So the N2 is valued.
N2.
N2, if N2 is 1, what does that mean?
It could be between 11 to 12.
N2 is 1, you have 11 units, right? If N2 is 2, you have 12 units.
Oh, okay.
So one mistake to avoid is, say N2 is between 11 to 20, because the value can only be between 0 and 10. Otherwise, this constraint won't satisfy, but you have the right one.
Okay.
Okay, then you just need to put the individual ones, N1, N2, N3, all need to be between 0 and 10. Okay, once you have that part, then you can think about, okay,
I don't have a.
what if, because they are all the number of newspaper ads,
Yes.
what if the solver give me like, okay, N1 is 5, and then N2 is 5. Does that make sense?
Yes.
Okay, so that's the part we'll say, okay, if N2 is greater than 0, that means we're already in the second group. Or should N1 be N1 is
And
better.
maybe
Oh,
10.
Oh,
That would be
okay.
10, right? Okay, so that's the part that we'll say, well, that's the one relationship that we want to make sure.
So could we do like, if N1 is less than or equal to or that would,
Sam, you gotta get an iPhone.
That's good.
Cool.
Yeah.
right, that because the other constraint will kind of keep this one as low as it can because it's the most expensive.
Okay, you're thinking the right way.
So N1 is less than or
You are
equal
trying to
to
maximize, think the other way.
Oh, I was just gonna say, like N2 and N3 equals 0.
Think the other way. Your objective function is maximize number ads reached. So what will solver try to do?
Oh, since this one is the most, we'll try to make this one the highest number possible.
Okay. Okay, we'll talk about it. It's all right, it's all right.
Yeah, I know.
My equation starts.
Okay, so well, as long as you are thinking about the relationship, I don't think
This is what we're thinking for, it's like, I don't know how you do it, but like, if this is greater than N2, this is fine. So really these two are, so as I said, these two are almost like the big inventory that we did.
so those ones, okay, so that's one thing to think about. Same thing.
Yeah, I saw that. I know. She didn't really go over the last problem, but it's online, so.
Yeah.
And that's what I'm saying, if we did this, like, it's almost like these would just be.
Oh, I gotcha.
That's like Mac can't do problem
Dependent on them.
Okay, yeah, but
So
we
that's
don't want
different,
that,
yeah,
we
okay.
don't want that way, we want to use them. Because
Oh, yeah.
they do have their role in function.
Yeah.
Yeah, I can't do that.
We do want these to be actually who we are.
I know.
And we do
I was kinda
want
surprised my
to
homework due already.
go if we are thinking third.
Or one
I
is,
thought it was gonna be
Yeah.
They are the,
last night.
yeah.
makes definitions, like it's. Because you're calculating from the 11.
Well, yeah, because they all can only equal 1 to 10, but then there's like another constraint where it's like, so like N2, 1 equals 11.
Yes.
But I don't remember.
I know, she's crazy. I gave her every test
This
already.
one is right. These two.
Because it needs to be 11.
That's, yeah.
It's one key.
You know, the reason we have this is because
Give you
our
N
labs,
and two.
Yeah, well,
because we compare one class, but our
We have an engineering wait, next week I think we do
Yeah.
I know.
That's
why I was one midterm and then a final.
Let's, okay.
That's what, we did the
Let's just settle
Yeah,
down.
Now we have 2 midterms.
I like playing about this.
So you have.
I like
I like one.
Exams.
Right.
I know.
What are you thinking?
Because she makes her.
Human factors.
I didn't.
Oh, yeah, so.
Actually, about that.
So I'm saying, obviously, yeah, this is,
guess so,
he's gonna be
Yeah.
0.5.
0.5.
Oh my God. With the light on it.
Yes. Okay, so, yes, so wait, let's hear about which one.
And then there's gonna be a save with all the constraints.
We don't want.
So if
all of that stuff, there's
What it is, this is my problem.
So it's like.
I know. What are we gonna do with this linear regression?
Well, we've been
And that's
talking about
inventory
stuff. Yeah, but like,
Okay.
I can't do it when the weather's not.
She didn't even know.
We're like, yeah, let's go to the colors, but we're asking.
like all of
We're like, are you gonna tell us?
Okay, so we'll talk about this here. I like that you guys are all really working on it.
yeah, well, she's probably insecure.
On the right track. So let's talk about this. I think everyone needs. Let me use a PowerPoint so we can. For which one is it? Newsline. Okay, so I think everyone got the decision variable correctly. So because the difference of number of customers reached and the cost per ad, it's just impossible to use just one variable for like newspaper ads. Okay, you have to do like, okay, if it's in like bigger than 10, you have to subtract the 10 or whatever. So that's difficult. So everyone find the right way to define your decision variable. N1, N2, N3, and T1, T2, T3. To represent the number of newspaper, I'll put here, number of news ads in group 1, 2, 3. Okay, number of TV ads in group 1, 2, 3. Okay, and we know the group 1, 2, 3. Okay, I'm not going to put it here. And the objective function is to, because they have a fixed budget, and what they want to achieve is that with a fixed budget, we don't go above the budget, but we want to reach the maximum number of customers. So the customer on the table, it didn't say per ad, but it is like 900 people per ad, okay? And 1 plus, what's that, 700, and 2 plus 400. Is that right? Yeah, 403 plus 10,000 T1 plus 7500 T2 plus 5,000 T3. Okay, and there's a very obvious constraint, which is the budget constraint. So 1,000 N1 plus 902 plus 800 and 3 plus 12K T1 plus 10K T3 T2 plus 8K T3 need to be less than equal to the total budget, which is how much on the other side? 145K. Okay, that's the constraints. And then the next constraint, next group of constraint is we want to make sure the way we define the decision variables work. Okay, and one, I think everyone got this one correct. So N1 is greater than or equal to 0, less than or equal to 10. Okay, some confusions were there for N2 and N3 value. N2, N3 value. So if we look back, review like how we define them, the N2 represent number of news in that group, in that 11th to 20th group. Okay, so their value can only go from 0 to 10 too, because even though it's the 11th, it's still 1. Okay, so for example, if our final result is like this, N2 is 5, then that means in total you have 15 newspaper ads. Okay, so one potential mistake will be put N2 as it's from 11th between the 11th to 20. So if we do this way, then if N2 equals to be 11, then we will end up with 21 newspaper ads in total. Okay, but the N2 is only the 11th unit. So that's one part. Want to make sure that's right. And then, so the same goes for the TV ads. Okay, so 0 to 5. T3 goes to 0 to 5. Then, I'm so glad you guys are thinking, okay, what about the solver just pick, like, okay, N2 equals to be 5, and N1 equals to be 9, and N3 equal to be, say, 4. That won't make sense, right? Because of the way we define, we say, okay, N1 should be the first 10, and you don't start with the, if it's a 5, that means the 15th, okay? And if this is a 4, it means it's the 24th unit. But you don't want this to happen. One way to do that is to put the if statement on them. So we don't want the group get jumped before the first group get filled. So if your N3 is greater than 0, that means you're already hitting the third group. Okay, what happens to your N1 and N2 value? If you are hitting the third group, you're already buying the 21st unit of newspaper ads. What does that mean? N1 and N2 need both be 10. Okay, and so we'll go backwards. Some of you went from N1, so I say if N1 is 10. But think about this: if N1 is 10, there's nothing you can force on N2 and N3 value. If N1 is 10, your N2, N3 can still be 0. What can be a 1, 2, 3 value? Okay, but if we go the other way, we'll say if N3 is greater than 0, then you have to this way. And if N2 is greater than 0, then your N1 need to be 10. Okay, so that's kind of like the way we define the definitions. But in this problem, we will be able to change those if-then statements into math models to write constraint when we are in chapter 6. Okay, chapter 6 is really, really useful. Like a lot of different situations that where the if statement we need to write, we'll be able to translate them. But in this case, we don't really need those. Okay, I'm very glad you are thinking about this. That's the first step. Then think about how the problem will be solved. Okay, we'll think about how to solve the problem. When you let me go back to the problem here. When you look at this table here, or let's look at our objective functions. Here. Oh, did I just discard my notes? Okay. So here, let's look at this. Let's look at the objective. Our objective is to maximize number of customers reached. Okay, and the only constraint that we had is the budget. Okay, then let's think about it. What we don't want is N2 start to increase. So let's imagine when the problem we put them in Excel, their initial value are all 0, right? These are all 0, 0, 0, 0, 0. These are all zeros. And the solver will find a way to find the values that maximize this part will satisfy those constraints. Okay, and when solver try to maximize them, which of those values, N1, N2, N3, T1, T2, which of them it will increase first? Maybe we'll look at, maybe this one, because it has the highest ratio. I mean highest coefficient. Like if you unit T1 by 1 unit, your objective function will increase by 10,000. Okay, and then it may go to this one or this one. But we also have those constraints. Okay, so now let's go to this table here. This table here. Let's go to this table here. Let's look at this one. Not able to write on this. So for those, the first group, the N1 group, it's 900 customers. Okay, customers. And the cost is 1,000. So what does that mean? For every $1 that we spend in N1 group, how many customers can we reach?
900.
Every $1. So would be this divided by 1,000, right?
Yeah.
Is 0.9 customer per dollar. Okay, so that's 0.9 customer per dollar we're going to reach. Then we look at the next one. Next one is 700, and here is $900. Okay, so then for this one, divided by 900, that's 0.78 customer per dollar. That will reach. Okay, and then the third one, 400 customers, and it costs $800 divided by 8. It's 0.5 customer per dollar. So for this problem, what do you think? Will solver choose jump? So this one N1, N2, this is N3. Will solver start to increase this value before N1 gets filled? Because for N1 it's the most efficient one, right? N1 is the most efficient. For every $1 it will reach 0.9 customer. This one, and that's the rate. That's efficiency decreases. Okay, so if you think about how the problem will solve, how the problem will be solved, we have how much money? I'll write the TV ones. Okay, so T1, T2, T3. I have those values calculated, so save some time. 0.83, 0.75, 0.625. Okay, so those are the customers per customer per dollar. Customer per dollar. Customer per dollar. Okay, so those are all the ratios for those ads. So when the problem starts to solve, we have 145,000 available. What will solver do? Which one is the highest? This one, right? This one is the highest. So solver will reach 10 there first. So N1 will reach 10. And that will cost how much money? 10,000. That's right? Okay, and we have how much left? 1, 3, 5. Okay, so that means we still have money to buy the next one. Which one is the next group? T1 will go next. Okay, so then T1 will see it can reach 5, right? 5, and what's the cost? T1 is 12, so 60,000. So buying all 5 from that group will cost $60. So we'll have 75,000 units left. And which one will be the next one? N2, right? N2 will be this one. This point we're looking at this value here. So this went first, second, then N2. So N2 will go next. N2 will be 10. And N2 cost 900. So we'll buy 9. So it'll be 9,000. So we have what? 6,000 left. Then we'll go to the next group, which is T2 here. Okay, T2. Then T2 will be 5. If we buy 5 of them, T2, that's 50,000. Okay, then we still have 16,000 left. 16,000 left. Which one else? No, this one, right? T3. So T3, let's see. We have $16,000 left. T3 cost 8,000. By two of them. Okay. So that's the way solver will solve. So very glad you are thinking about the relationship. The N2 should not go beyond go positive unless you hit the first. You fill the first group. You buy the first 10, and then you go the second 10. You go the first. But like in this specific problem, the way because the budget one, the budget constraint. This one here. The budget constraint is the only constraint. There's no others. If they have other constraints that makes the problem more complex, then we won't be able to analyze this way. But in this case, that's the only constraint. Then it's basically, okay, we think about how efficient each of them are. And then we don't need to have those constraints, the if then else statement. And this is how the problem will be solved. And the way solving it is called a heuristic approach. Heuristic is like based on your rule of thumb thinking, and then you try to work through the problem. And that's and those are all the constraints we have. So we'll have the n's and the t's. They have their bounds, upper bounds, and they also have like non-negative constraints. Okay, but if we don't analyze it, we'll have those constraints. Okay, if n2 goes beyond goes positive, we study in the second group, then n1 need to be 10. If n3 is going positive, then both n1 and n2 need to be 10. Same for the newspaper, same for the TV ads. So for this problem, number D. Number D says, here, suppose the number of newspaper reaches by the 11th to 20 newspaper ad is 400, and the other is, now they switch. What do you think will happen if we use the original model?
It won't work.
Okay, solver will still work, right?
Oh.
It will tell you a wrong answer. Okay, if we still use, if these two switch, if this 400, 700 switch, then the efficiency will change, and then what do you expect?
Then solver's gonna wanna do
N3 before N2. So you will get N1 equals to be 10, N3 equal to be 10, but the N2 will be, is that the 0? Yeah, so N2 will be 0. Okay, so that's one problem that we want to illustrate, the thinking about the relationships. Like in this one, it's impossible to use just one variable to do number of newspaper ads. So we use the 3. But when we use 3, we need to think about the relationship between them. And there's a way to define. And in this specific case, by thinking about how the problem is solved, we can avoid those extra constraints. But if we do need them, we need to write them out. Okay, we'll talk about that more in chapter 6, how to translate them. But here, just one example. Okay, then the next one we want to do, another interesting one. That's the 16, 19. If you have a version 6. If your book is version 5, it's the 16. It's I'll show you this one. It's this one. This one is on. Okay, you can look at mine if you don't have it. It's this one. On your 6th edition book, it's 19. I'll ask you to do that first, and then we'll work together. We'll implement this on Thursday. I'll ask you to formulate yourself first.
Performance. So this is kind of like a compressed one. Would be like
Yes, it's like the investment problem in the way that you need to do some analysis first before you can write the model. Like in the investment problem, we did like a table to do some analysis. Or think about the decision variables first.
Okay.
See, that's what I didn't understand.
Yeah, I wrote this really wrong.
Yeah. So, alright, so.
So read through the problem statement.
Well, the decision number of least at that month.
Times me for 4 months.
Yeah.
But I think that like. So this would be like we have to like more space first.
Kind of seems like the,
But that's
because it's like, how many square feet do you use at 1 month? For 1 month versus how many square feet do you lease
So I
at
think you're only
1 month?
using this one then.
Yeah.
For 2 months.
And yeah, I guess
And then,
you
like,
just have
each
wasted
month.
time here. Yeah, you just have wasted space there.
It's like a different.
So you're still trying to find out if that's wrong, so then you're wasting space, but it might be cheaper.
Any problem understanding like how they work? Maybe a little, like so like in at the beginning every month, like month 1 they can just lease how many square feet for 1 month, and the unit cost would be just $55. So it does those costs does not change like per month. It's just like, okay, if your lease term is 1 month, then for all the square feet you lease for 1 month, it's $55. If you lease in the beginning of first month, you lease for like 10 square feet for 3 months, then it's 10 multiplied as 130. Okay, so you can lease 1 month, 2 months, 3, 4, 5 months, and those are just the unit cost. And you lease to fill your need. Like in the first month, you need 20,000 square feet. And in the first month, there are many different ways to lease. And the square feet you lease will help you meet the needs in the first month, and maybe second month, or maybe third, fourth, fifth month. Okay, so we can do some analysis. Any or any ideas the decision variables should be? The decision variables. Okay.
Yeah, no, it's like an investment.
So your idea is
Because you can keep the square footage like you have, but you can get
okay.
Then if you are,
Okay.
you have to only do it for, like, do it for 1, 2, 3, or 4.
Oh, I see. Okay. Consider you because what you were saying is that this is L1 represents total amount of 1 lease, 1 month lease, from
No matter
okay,
what.
so you can
no
hold
matter
the
what.
right now.
If you are going to need these numbers are the amounts.
This works perfectly.
We're already starting with the second one, you're not going to talk about the ending.
Yes.
You're going to already solve it.
On the right side, you just
Oh,
because here you can
Yeah,
do
that's
this
probably
without
right.
think about the
I thought that would be a constraint.
So like,
that
you
makes
could
sense.
lease like 50,000 square feet,
So if you
That's probably
because
So I think
But then you're just like,
Yeah, but that doesn't
Because that month
It would be
one
square
is-
foot, you lease for 1 month square foot, 2 months square feet.
Right.
For the next one, you can do it for 1 day.
But then after
Feet
the
for 5 months, right?
And then.
it has to be.
But then you have that decision for each
This is
month.
what makes it easy. It makes it easy.
Because the options would be
Then the second one is still.
Okay, what else is
Oh, okay, now we're good. So I think it's 25.
first month they
No, so what if you did two days, like, starting with month 5, going to.
So I think like each month you have 5 options in 5 months. I guess you have like, I guess you have 5 options, 4 options, 3 options, 2 options, 1 option.
So it could be like
Yes.
20,000,
Because you don't want to
but
lease
then
more right off the bat.
Oh, okay.
10.
So you have 5, 4,
It's like 20,000 for 5
I see
plus
what you're saying.
10,000 for
Okay,
4
okay,
months.
okay. Just want to see where.
5, 9, 22, 25, no wait.
It's like 20.
No, you- 9, I added on, 12, 15 options.
Yes.
Is there 15
You would say, oh, perfect, for.
I think it's,
But I would go back down, you're not gonna wanna.
I think it's more than that.
I didn't, what you have,
Okay, okay, yeah,
so,
that's.
for this is for month 1,
I
right?
see,
And then
I
month
see.
2 you'd have
Okay,
4
okay.
options.
So you, this is your month one, yes.
Yeah, and then you'd have month 2 would be just 4,
Okay, I see what you're saying.
and then month 3 would be.
You buy this.
Uh-huh, right,
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 okay.
right, that's right.
Okay, that's what
Or
I
you can do just like a 5 for each month, and then like, for example, you, like it doesn't make sense in the
It should
second
be
month
0
to
and 0.
5, then it will be.
Okay.
Okay,
Yeah.
okay, great, okay.
So your lease.
This is yours.
So you could do
Oh, I
just
haven't written anything.
Okay, your decision variables. This one, calculation.
Yeah, I'll just use it as a.
Okay, this,
I don't know, that's okay.
okay, it's okay.
Yeah, I don't have it.
Okay.
And then you're wasting on space.
Okay, we'll talk about it. So the decision variables.
I know what's going on. I don't know what we're doing.
Well, you're the layer setting.
Okay.
You're saying if you use 20, then I'll add numbers to get rid of it.
It's kind of big.
Oh, yeah.
For this, I don't, you can't. Because that's not, there's one rent, you're saying either it's commission.
I've actually, but we have to consider the fact that we
Okay, that's okay. So, our decision is to determine how many square units to rent. Okay, so we'll talk through this problem. So our decision is to determine how many square feet to rent per at each month. Okay, like for example, in the first month, you're going to determine how many square feet I should lease for 1 month, and how many I should lease for 2 months, how many I should lease for 3 months, 4 months, 5 months. Okay, and then in the second month, again, you're going to determine how many I should lease for 1 month, 2 months, 3, 4 months, 3 months, 4 months, and probably not for 5 months. But that's okay if you put it there. It just turns to 0. Then in the third month, again, you're going to decide how many am I going to lease for 1 month, 2 months, 3 months. Probably not 4 and 5. But you again, you can list them here. They will be just 0. Okay. So the decision variables really. So let's put. I'll use this one too. So that's the leasing problem. Okay. So the leasing problem.
So we're talking like L11, L12. So
Yes, yes, yes. Okay. So what going to do? I'm going to use Xij to represent the square feet to lease in months I for J months. Okay, so that's the way I choose to do. Many of you had xi representing the square feet to lease for j months. Okay, so that's on the right track. Many of you had this one, the square feet to lease for j months. It makes writing the objective function pretty easy. So basically you use the unit cost and some product of those ones and the unit cost. The problem for this one is that we won't be able to differentiate whether it's the first month or second month, third month, 3 or 5th month, because we do need to meet the needs in those specific months. Okay, and if you think this way, then we need to think about that in each month. Okay, so then that goes to here. So in each month, we need to think about how many square feet to lease for the specific term. That's for j months. Okay, now, then we'll do some analysis. So objective function, pretty simple. Basically, if your j is 1, that means it's like a 1 month lease. So 1 month lease, that's 55 times. I'm going to do the summation here. I1. I goes from 1 to 5. Representing the I1, it's x11 plus 21 plus 31 plus 41 plus 51. Because what matters, what determines this unit cost is the months, the length of your lease, which is like how many months you lease for. Okay, plus second one is 95. So 95 x I2. Again, I goes from 1 to 5. We'll make it general. In some cases, we won't lease that many, but 5 x I3 plus 155 x I4. And the last one, 185 x I5. Oh, summation here. So that's the objective function. Now for the constraints, basically we need to meet those demands. Okay, if we look at the problem, in the first month they need 20,000 square feet, and those ones can be this demand here can be met by which ones? If you lease in the first month, you lease for 1 month. That will help cover this one, right? If you lease for 2 months, that will help cover this one too. 3 months, 4 months. So to make it easier, let me just draw this. So this is our months. So months. So this is my months. Months 1, 2, 3, 4, 5. Okay, and that's like the term length of the. Okay, and here is months 2. Months 1, 2, 3, 4, 5. I'm going to do this analysis. I saw some of you are already doing this. So in the first month, I can lease for just 1 month. Okay, and I can also lease for 2 months. I can lease for 3 months, 4 months, and 5 months. Okay, and then starting from the second month, again, I'm moving to here. I can lease for just 1 month, 2 months, or 3 months, or 4 months. Okay, I can lease for 5 months too, but we know it won't be economical. We're just not going to waste the time there. So then in the third month, I can lease for 1 month, 2 months, 3 months. The same, in fourth month, I can lease for 1 month, 2 months. And in the fifth month, I can lease for 1 month. So those represent all the options. So I can put it here, x11, x12, x13, x14, x15, x21, x22, x23, x24, then x31, x32, x33, x41, x42, x51. Those are all the options that we listed our decision variables. And we know that in month 1, we have a demand here, which is 20,000. And we did the analysis, we said, well, to fulfill this need here, all of those ones, 1, 2, 3, 4, 5, all of those ones can help me fill this need here, right? Does that make sense? Take a look.
Yeah.
Okay. And then, what about in second month? I have some lasted from, that at least from the first month that will last until the end of this month. I also had some, like at least from the first month for 3 months, that will last until the end of the third month, but got this month covered here too. Okay, same for the fourth and the fifth. And I also have some new ones that I leased in this month, those ones. They have different lengths of the lease, but they all got this month covered. Okay, so to meet the needs here, this 30K here, all of those ones can help. Then that's the same for the rest of them. So the 40K, 23, 35K, and the 50K here. So basically, can you write the constraints now? These ones are going to help fill this need here, and these ones are going to help meet the needs here, and this one, 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 this one. These ones can help meet the needs here. Can you write the constraints now? Okay. Great. You got the same. Okay. Okay, so let's write the constraints. Were you on the right track? You're doing something.
So I was just,
Okay, yeah, sure, that helps. Yeah. Putting some real values and everything. Okay.
I think this is how you write your constraints. So
yeah.
Okay.
Oh, I got it.
You got one.
Yeah, so like, so this would be your sum in
Okay,
J terms,
okay,
so
okay,
1,
yes.
20, and then you have that added, and then. you can
Okay,
turn
so
it
yeah,
around
great.
that way.
So this one will change start from 2. Yes.
Yeah, but then you
Because you
have
start
4
from
and
2.
1 to
Yes.
eliminate that, and then you have 3 and 1, and it
Yes.
keeps.
Yes. This number keeps changing. Yes,
Yeah,
that's right.
but then you have to have the non-negative.
Yeah. Yeah. Okay. Okay.
It's confusing though.
So it's the sum of the
Yes.
response rate.
Yeah,
Okay.
but then when you go to the second month,
This is like a,
you can't start at 1,
this
you
one,
gotta
this is
start
like
at
a
2, and then this, your
Okay.
4 values, because you don't have 5 values.
oh, like a why you have a guess? This
So
one
you
costs-
hear it too.
Like it's such a.
Because you can't have 1, you've already done 1.
So we would define that inside the J here.
That's what I'm just.
So when this is a 1, that means all
Got it.
the.
Okay, so this
is different.
So just,
In all the items,
That's just gonna try to
where you sum
that you're making the 1 point.
Because that's the 1 month, so they're
And you're
costing
making it for
$55.
another.
So we take it.
That's another $10. Yeah.
So here, this.
How am I gonna do this in 10?
I won't.
That's
That's my group.
Maybe it's take.
I heard.
And then we do, so you do a 3 month.
Yes.
For 5,000, and then a 1 month for 5,000, because then after that month, we have to do
You could do worse, it could be.
Setting the studies for
Oh,
this.
you're-
I don't know, this.
No, I-
one of the better.
Okay. Okay. Yes.
That's what I mean.
They are, yes.
Because I actually get the carry
I see she did. She just added for group less where you can get into.
Yeah,
So just
that's
be
all I
able
was
to
saying.
read.
Yeah, they can do remote, and they are so
I thought she was using
right.
that. Yeah, I see now
Okay,
because
sure.
minor groups, yeah, minor groups wise, I get it.
So we can do, so the first month, or Martin, do you want to share your constraints? Okay. So the first month, so the long way to write it is like this, right? 1, 3, x1, 4 plus x1, 5. Greater or equal to the 20. We'll use 1,000 as the unit, okay? And the short way to write this is x. So what we care about is the first month. So 1j. J goes from 1 to 5. Okay, that's pretty obvious for the first month. We'll do the second month. So for the second month, it's x12 plus x13 plus x14 plus x15. And then, so that's from the first month. Then second month, x21 plus x22 plus x23 plus x24. These ones greater or equal to 30. Or do the long way first. Then you will find a way to just shorten them.
Yeah.
Anyone want to know how to write this? Short? Martin, can you share yours?
For the second one,
Yes.
it's the sum 5,
Sum of
2's on the bottom and 5's on the top.
2, 5.
Yeah, x1j.
It's a J, right?
Yeah, that's j at
Sorry.
the bottom. You can't do
It's
that.
on the edge of this. It's a little hard for me to write. So it's J goes from 2.
No, that's 2.
Let me write it here, okay? So that's the first constraint. I'll write the second constraint here. So it's J goes from 2
And 5.
to 5. X
For x1j. Plus
1J plus
the sum from j equals 1 to 4
1 to 4,
of x2j
2J. Okay,
greater than or equal to 30,000.
30. Okay. And once you write more, you would notice that because we are covering each month. So the first month, the I here is just a 1. Okay, and you go like all the way to, because you start from the first 1 month lease, 2 months lease, all the way to 5 months lease. So the J goes all the way to here. Oh, sorry, I missed this. Greater than or equal to 20. Starting from the second month, we know that those ones won't work, like this one. So the x11, this won't cover the second month. So you start from J2 here. J equals to 2. You start from this 2 here. So this is the J equals to be 2, 1. Then you go month 1, you start from, 2 months lease, 3 months, 4th, 5th month, 5 months lease. Those are all be able to use to cover second month, and plus the new ones. So you can go, this is subscript, the I is 2 because you are in the second month. So you use the second month's lease, and this J can go all the way from 1 to 5. But we know we won't go to 5 because you are already in the second month. It does not make sense to lease for 5 months. And then, should we finish the So then the third month, let me add another. No, keep. Okay, I'll add another slide here. Okay, so then we'll do the third month. The third month would be way. Think about this. So from the first month, 1-1 you won't be able to use because you covered the first month. 1-2 you won't be used either. You start from 1-3 because that's the one that goes like the 3 months lease that will cover the third month. Okay, and the 1-4. It will be much easier to refer back this here. But if you really want to know like the shorter way to do it, I suggest in the exam, if you're not really sure, just write the long way. Okay, just write the long way. I don't want you to get confused in the subscript things and end up losing points. You know how to do it, but just didn't write it correctly. Okay, just write the long way. So it will be like 1-5. So this is from the first month. Then the second month, we know if we rent for the 1 month, it won't cover. But starting from the second one, so 1-3. Oh, sorry, 2-3, 2-4, and we won't lease for 5 months. So that's it. Then the third month we can do 1, 2, and 3. Those will all help fulfill. We won't do 4 and 5. But if you write 4 and 5, that's not wrong. You can do that, and that's greater than or equal to. So it's basically those ones, 40. Then in the fourth month, this one you cannot use anymore. So 1-4 plus 1-5. Every time you just shift a little bit. Then x2-3, x2-4. Because 2-2 you won't be able to use it. Then 3-1 you won't be able to use it. 3-2, 3-3. Plus, this is the fourth month, I can rent a new one. So 4-1 plus 4-2. We won't do 3-4-5. So greater than or equal to 35 here. 35 here. And then the last one, x1-5. At least for 5 months, so that's covered. That's going to cover the 5th month. And x2-4 here. And x3-3 here. x4-2. x5-1. Those are the only ones that we can cover the 5th month. So it's this one, this one, this one, this one. So it helps to have that graph. Oh, forgot to. So that's the 50K. So that's the model, and you have the xij rental to 0. And if you really want to know the short way, we'll just keep switching the j's. So in the third month, j will start from 3. This j will start from 2, and you add another one. So it's x1 j start from 3 now to 5, and then x2 j start from 2 to 4, and x3 j start from 1. You keep switching, and this is going to 3, rental equal to 40. So that's the short way of writing this one. Okay. And non-negative constraints. Any questions? You had enough. Okay. I'll see you on Thursday. Yeah, sure.
Thank you.
You get the bonus. Did you upload the Excel too?
I did yesterday, yeah.
Okay. Yeah, if you have homework you want to turn in for the bonus, you can do it now.
So if we wanted to hand in homework for extra credit on a Monday or Wednesday, would you count like the online submission as
Online and the paper part.
So you would want us to drop off the paper drop?
Yes.
Did you want them to get an email by chance?
Which one?
My email that I
Yeah,
sent
no.
yesterday.
Did you do it?
So I did it with Aaron, and we
Oh,
worked on
Aaron
it.
mentioned that.
Yeah, so we worked on it for like an hour, and then like
Just like the mag of the problem, right?
it might be, but like I don't, because like when he did it too, it, like you know like the decision variables are like all like scattered on it for the second one. It came out with a number.
Right, he described that.
Yeah, so I don't know. And then you mentioned today that, you know, it could get confused with having big numbers. So I put it in like 12K.
Okay, sounds good. Yeah.
12K and like 800K. I don't know, I sent it to you in that email.
You didn't receive it.
That's really weird.
You sent it yesterday?
Did I? Oh gosh, I have this.
Yeah, I just always like hold it. I don't have a stapler.
Okay.
Works.
Okay. Good.
I did, yeah.
You did send it? I
Yeah.
didn't receive it.